So this was the 2010, this is like their Form B of 2010 for your response, the calculator section. So my toolbar disappeared. Off to a good start here. All right, oh well. So for part A, we were looking for the area of that region, right? And so the area of that region should be the integral from the leftmost, 0, to the rightmost, 2, of the upper function, which is y equals 6, minus the lower function, which is 4 natural log 3 minus x dx. And just having this is worth 1 point. And then the second point for this one was just getting the answer. And you should have plugged that into your calculator to get what value?
6.8167.
6.8167, we'll round that to 6.817. Always round to at least 3. You can always go more than 3 decimals if you want, but you need at least 3 decimals for any of the questions on the AP test where they require you to use a calculator. And then it also said in the scoring guide, so it's 2 points for this first part, but it also said that if you had the correct limits in any of the integrals for A, B, or C, they'd give you a point. So you got 1 point for having the right limits there, 0 to 2. So sort of 3 points there. All right. Any questions on part A?
I have a question. Why is 4 natural log of 3 minus x not integral? Why can't we do that? Like, can we use substitution, or does it not work at our level?
I mean, you could, but you guys haven't learned how to take the integral of the natural log function. It requires a method of integration called integration by parts, which is a Calc 2 topic. So. Okay,
just curious. Thank you.
Yeah, I mean, it's possible to do it. I mean, it's not. I mean, the integral of natural log of x is x ln x minus x. But in order to get that, you have to be able to integrate by parts, and that's not part of our curriculum. So that's why it's a calculator question. This could be on the BC test as a non-calculator question easily enough, though. So. All right, on to part B. So for part B, we were looking for the volume of the solid that you get when you revolve R around the line y equals 8. So we know it's going to be pi times an integral from 0 to 2 again here. Given we could probably find a way to do this with shells, but it'd be a lot more complicated. But if we revolve around a horizontal axis, we should slice vertically to get dx. And we should look for our outer radius, which will be the distance from y equals 8 to this function, and our inner radius, which will be the distance from y equals 8 to y equals 6. And since this piece is just f of x, and the whole thing is 8 units, what should our outer radius be? Should be that full 8 units minus f of x. So 8 minus 4 ln 3 minus x squared minus our inner radius, and that's just our 8 minus 6, or 2 squared dx. 2 points for having the right thing in the integral. And what did you get for the answer there?
53.533.
I think you might have forgot to multiply by the pi.
Oh.
I got 168.1795.
1795, so 180. And that should be worth 1 point as well. So 2 points there, 1 point there. Good or no?
Good.
All right, let's take a look at part C. So now we've got the region R as the base of a solid. And each cross section perpendicular to the x-axis is a square. So if the cross section is perpendicular to the x-axis, then what variable are we going to do this in?
dx.
Should be in terms of x, with the dx as the thickness of each of those squares. And that square should be extending out like this, so that the length of one of the sides is the distance from 6 to our function. Okay? So what should s equal? It should be 6 minus that y value. I got a little mark there that makes it look like a negative, so get rid of that 6 minus y. And so we should get an integral from 0 to 2, 6 minus, and then our function is 4 ln 3 minus x. And since it's a square, it should be the side length squared dx. This is worth 2 points. And what was your final answer?
26.266 units cubed.
266. Sounds good to me. And that's worth 1 point. And so those are your 9 total points. 1, 2, 3, 4, 5, 6, 7, 8, and then 1 for having the right limits in any of the integrals. So 9 total points. How'd that go? Pretty good? Not so good? Okay.
Good.
Good. Some of you, I hope, got 9 out of 9, but hopefully most of you got at least like 6 out of 9 on it, because that puts you in good shape to be right around a 4 or a 5. All right, let's do another one. Unless anybody have any questions on that? All right, here is the next one. This one is a non-calculator, so no calculator for this one. Non-calculator, and you'll note that part A has nothing to do with area or volume. So you got to think back to some stuff we did a long time ago. And I'll give you 15 minutes to work through this one, and then we'll go through it. Ready, go. For this one, which was, I believe, 2011, the 2011 test, part A had absolutely nothing to do with area and volume. We just wanted an equation for the tangent line to F at a half. So if we want to write the equation of a tangent line, what do we need?
Slope.
We need a slope, and to get a slope, we need to take a
Derivative.
derivative. So f prime of x should have been
24x squared.
24x squared. We should have evaluated that at a half to give us 6. And that was worth 1 point if you got 6. And then you needed the point. So we needed to find what f of 1/2 was. And what was f of 1/2? That'd be 1/2 cubed, right? Which is an 8 times 8 should be 1. So the equation of the line should be y minus 1 equals 6 times x minus a half. And that was also worth a point. Everybody good with that?
Yep.
Okay. Part B. So part A there was just worth 2 points. Part B got a little bit more difficult with the area here, just because of the integral of sine pi x. So to find the area, we need to integrate from 0, our lowest x value, to 1/2, our highest x value. And we need to do the upper function. Which one is the upper function? Is that 8x cubed or is that sine pi x?
Sine pi x.
Should be sine pi x minus 8x cubed dx. And so that was worth 1 point if you had the appropriate thing in the integral there. And what's the integral of sine pi x? Hopefully you can do that little u sub in your head and just write out the answer for that. That should be -1/pi cosine pi x. Everybody good with that or no?
Good.
And then minus 2x to the 4th from 0 to 1/2. And getting that was worth 2 points, having the right full antiderivative there. Then you need to plug in 1/2 and you need to plug in 0. So negative 1 over pi cosine pi over 2 minus what's 1/2 to the 4th. Should be a 16th, and then times the 2 should be an 8th. And then we'll subtract negative 1 over pi cosine 0 minus 0. And the cosine of pi over 2 is what? That should be 0. So that whole term goes away, right? And cosine of 0 is 1. So we end up with negative 1 over pi, which would be positive 1 over pi minus 1/8. And that was worth a 4th point for that part. Any questions on part B? All right. Unless I'm missing stuff. Yeah, no, nobody's saying anything in the chat. All right, that's good then. Part C said take this and revolve it around the line y equals 1. And write, but don't evaluate an integral expression for that. So first off, we're going to revolve around a horizontal line. Cross sections should be done vertically to get discs or washers. Those would be washers, right? So we're going to do pi times the integral from 0 to 1/2 of our outer radius squared minus our inner radius squared. And our outer radius should be the region, or not the region, but the distance from y equals 1 to our lower function. And the inner radius should be the distance from y equals 1 to our upper function. Good or no?
Good.
All right. So what is the lower function? That's our 8x cubed function. So we have 1 minus 8x cubed. That's the distance from 1 to 8x cubed. Square that, and then subtract the distance from 1 to sine pi x. So 1 minus sine pi x squared dx. And for that one, you got 1 point if you had the right limits and constants, and 2 points if you had the right integrants. How did you guys all feel about that one? Everybody feel pretty good about that one or no?
We feel amazing.
Wonderful. Did you get 9 out of 9 on it?
No.
But now you would if you saw a similar one. Hopefully.
Yes.
Totally.
Yeah. Well, the more of these we do, the better chance you have of getting them all right. So down the road. All right, we're going to do one more. We won't have time to go through it today, but I want you guys to stick around and spend the 15 minutes right now working on it so that you don't have to do it this weekend. And then there's one more on this notes page afterwards, which I'll save up in the, it's already saved up in the blank notes folder, but it'll also be saved up with today's lecture notes. So I want you guys to do the last one on your own sometime this weekend, so we can go over both those first thing tomorrow. So first one that we will go over first thing tomorrow is this one, and it is a non-calculator one again. So this one's non-calculator, and then the one that you guys will do over the weekend on your own is a calculator one, but it'll have calculator written at the top. So this is our last one for the day. You got 15 minutes, then I'll just check in with you guys at the end, and we'll go through it on Monday. Ready, go.